Okay, here is a quick walkthrough of the solutions to a recent quiz, which should help you along with the work that you're doing now in Unit 9. For question number 1, you can pause the video and read it if you don't remember this question. But we're looking for an equation of a line that's parallel to a given line that passes through a given point. To build the equation of a line, you need two pieces. You need the slope and the y-intercept. So the question is, which of the four solutions here match the equation we're looking for? Well, first of all, to figure out the slope that we'll need, you'll need to get this equation into y equals form. So by subtracting 5x from both sides, you can quickly get the y by itself. And the number we're going to need to look at is this negative 5. We need something that is parallel to this one. So we'll need the same slope. So very quickly I can tell that it can't be choice number 1. That would be if it would be perpendicular. And same for number 3. So we're looking for the same slope, so it's either choice 2 or 4. And that's where this extra point comes in. They're telling me that the x is 5 and the y is 3. Since I know what the slope is and I don't know what the y-intercept is, I can use y equals mx plus b and plug in the information that I know. The y is 3. The slope that we need to make it parallel is negative 5. The x that they're giving me is 5. And the one number I don't know is b. So by just doing some quick arithmetic here and solve for b, I'm going to try to get b by itself here. I'm going to add 25 to both sides, which gives me 28 as my y-intercept. So it would have to be choice number 2. You could have also just plugged these numbers in to both of these choices to figure out which of the equations would work out. Moving on to question number 2. Question number 2 is also a question about parallel and perpendicular. And you can see my work here quickly took apart this equation and got y by itself. And on this equation, the same thing, got y by itself. So you can follow that, I guess, on your own. So at the end, we're going to take a look at the two slopes here to make a decision if they're parallel or perpendicular, or neither. So looking at these, one is 3 over 2 and the other is 2 over 3. Those are called reciprocals. The fractions are flipped, but they're not negative reciprocals, or some people call them opposite reciprocals. Because they're both positive. So if one of these slopes was negative and the other one was positive, then we'd have negative reciprocals and it would be perpendicular. So for this particular result here, right here, we know they're not parallel, they're not the same equation, they're not negative reciprocals, so it would have to be choice 4. All right, moving on to question 3. We're dilating equations in question 3. And when you're dilating equations, you have to pay attention to the center of the dilation. If the center of the dilation is touching the line, then the line won't move. If the center of the dilation is the origin, as I wrote here originally, then it becomes very easy. You would just take the y-intercept and multiply it by the scale factor, which would give you negative 1/2 x plus 6. And none of those choices are there, and that's because the center of the dilation was not at the origin. The center of the dilation should have been at 0, 1. So the y-intercept is not going to be 6. When we dilate, the lines stay parallel. So we're looking for an equation that has the same slope as our slope here. So we know it can't be choice 4, which has a slope of negative 2. So since the slope has to stay the same when we dilate, we know it's either choice 1 or choice 2. Well, the center is actually located at 0, 1 instead. And when we dilate the purple line at that center, it will bring the line, or the image of the dilation, closer to the purple line than if the center of the dilation was lower. So it does make sense that it would be choice number 1. It would be choice 2 if the center of the dilation was touching the purple line originally. One nice little way to think about these is to think about the way we did our dilations with a compass. When we did our dilations with a compass, we put our needle down there on red, and if we did a dilation of 2, we would open our compass and swing it twice, which would actually push the y-intercept to 5. And that's another way to visualize what's happening here when you're doing the dilations, and the dilation is not at 0, 0. All right, next up is question 4, and this one should be pretty straightforward. We're looking at a circle's equation here, and I can tell because of the form that it's in, and it's in that very convenient standard form. So reading the center is as easy as just changing the sign on the x, the number near the x, and changing the sign on the number that's along with the y. So it would be -1, +5 is the center, so it eliminates 2 of the choices. And to figure out the length of the radius, there's a 16 at the end, so the radius squared would be 16. So to get to the radius, you square root. So it would be choice 4. For these questions, do pay attention to whether they're talking about the radius or the diameter. Sometimes on the trickier questions, they'll actually ask you for the length of the diameter. And if that was the case, if the radius was worth 4, then the diameter would be worth 8. For question number 5, it's also an equation of a circle, but it is not in that convenient form that it was in question number 4. So our goal here, first of all, is to make this equation here look like this equation here. And the way we do that is with a technique called completing the square. I've nicknamed it split and square. And what I noticed on the quiz was that probably the biggest mistake that was made by students that were attempting this was at the very beginning, putting the 17 to the other side of the equation. You'd have to subtract 17 from both sides, which would make it a -17. So that sign mistake there actually threw off at least 10 of the students' answers here. All right, so let's talk about splitting and squaring. My first step here in black was to organize it so that the x's are next to each other and the y's are next to each other. And that 17, again, got subtracted away from both sides. Now I've left myself some blanks here, some parking spaces, so that I could actually work on that technique called splitting and squaring to arrive at the convenient-looking equation that I've already started writing down here in white. So the number that we're splitting is -10. When you split -10, you get -5. So we've split -10. Now in white there, I've got a reminder of what to do next, is I'm going to square the -5. So -10 split in half is -5. -5 squared is -5 times -5, which is +25. So to make the perfect square trinomial appear, I had to split the constant term and then square it. Whatever you do to one side of the equation, you have to do to the other side to keep it balanced. And then we go on to splitting the constant term that contains the y. So that 2 split in half would be 1. So there's the splitting, and then the squaring coming back up. 1 squared would be 1. Whatever I do to one side, I have to do to the other side. -17, 25, and 1, when you add those together, it sums to 9. And from there, it's just changing the signs to figure out your center. So the center would be +5, -1. And the radius squared would be worth 9. So the radius would be worth 3. looking at that question number 6, this actually did happen on the exam, the June 2010 exam. There was a question that involved something that the New York State Regents called a rectangle, and it wasn't a rectangle. And I've already given myself a head start on this question here. To look at and to be able to identify different shapes in terms of what they are, knowing their slopes and lengths can be very helpful. And on this grid right here, I could easily count the slope of these two sides here in black as being up 5 over 4. And these look parallel, and they are parallel because from A to B, the slope is also up 1, 2, 3, 4, 5 over 4. So those matching slopes mean that these two sides are parallel to each other, which is not what I need to figure out, but it's actually something that's true. Those sides in yellow, if I look at their slopes in yellow, those are going down. They're going down 2 over 1, and this one matches as well, down 2 over 1, and that's what I wrote here. So now on to the question. It says, explain why they made a mistake. Explain why it's not a rectangle. Well, taking a look at these slopes right here of these connecting sides, the black sides and the yellow sides do have different slopes, but those slopes are not negative reciprocal slopes. If they were, then we would have a right angle. So we know that there are not 4 right angles. In fact, there are no right angles. So none of the angles are 90 degrees. Now if we had 5 over 4 for one of the slopes, and the slope here was negative 4 over positive 5, then that would do it, and it would create the right angle. So as you notice, I left this length column blank. You could figure out the lengths, and there is nothing that would be wrong about that. As it turns out for this question, though, it wouldn't be necessary. But I will show you very quickly the lengths if you've forgotten how to do that, and actually it helps with the next question. So to turn the slopes into lengths, we use those numbers, and we square those numbers and square root it. So 25 plus 16 would be 41. So the length of side AB is radical 41. And the same thing applies to side DC. It's the same exact numbers. As for side CB and DA, it's also the same calculation, 2 squared plus 2 squared, which would be 4 plus 4, or radical 8. And there's no need to recalculate it since it's the same numbers there as well. And as you can see, the slopes were the same on opposite sides, so it's a parallelogram. As it turns out, the lengths are the same on opposite sides as well, which reinforces the idea that it's a parallelogram. But the lengths won't help me answer this question. To be a rectangle, it has to have those negative reciprocal slopes. All right, on to questions 7 and 8. For question number 7, they're asking me to calculate the length. And to calculate the length, just like I did in the last question, we can use the slope and use the numbers from the slope to calculate the length. As it turns out, graphing this segment would be a little bit difficult to do on a normal sheet of graph paper. You could scale the paper down somehow, but that point is really out of bounds on most sheets of graph paper that I've seen. So instead of actually figuring out the slope by counting it, we'll figure out the slope by using the slope formula. So the two y's in the question were 52 and 2, and the two x's in the question were 146 and negative 4. So 50 take away 2 is 50. 52 take away 2 is 50, and 146 take away a negative 4 is the same thing as 150. So the slope is 50 over 150. can take those numbers. I wouldn't reduce them. I would just take those numbers and place them under a radical like that and square them. So as it turns out, I'll end up getting my answer. So that comes out to be the square root of 25,000, which is not something that I know by heart. So I typed that into a calculator and rounded it to the nearest tenth. It's choice 4. Okay, moving on to question 8. One way to start the question would be to actually draw a picture of two triangles that are similar to each other. It says the triangles are similar and they want to know which one is not always true. Well, drawing a picture like I did here makes it at least obvious to me that if it's triangle ABC and it's similar to triangle LMN, then angle A must be the same as angle L. So these two angles must agree in terms of their size, but there's no reason why A would have to agree with angle N, and that is the correct choice. Alright, that brings us to our last question. It's a proof. It asks us to prove that the two triangles, the larger one and the smaller one, prove that they are similar to each other. So I've already color-coded what they said in the given, that these two angles were the same. And that's half the work right there. To prove that triangles are similar, to prove it, we're going to lay out a statement and reason column. And you could say the fact that they gave me in yellow, I placed down there. It's a given fact. And I hope you do remember that to prove that two triangles are similar, they have to have the same angles. And you don't need to actually prove that all three angles agree, just that two agree. We already had one right off the start, one set or one pair that agreed. So the only thing left to mention is that angle A happens to be in both of those triangles. Angle A in the smaller triangle is equal to angle A in the larger one. And an explanation could say that the triangle or the angle is in both triangles, or you could use the word reflexive to cover it, and that was it. So you be sure to have a nice day, and hopefully this cleared up some of the small problems you were having, or maybe some of the big problems you're having.